Okay, our next talk will be enhancing groundwater surface water interaction modeling in Texas. And our speaker will be Guillermo Martinez. Guillermo is a senior hydrologist and civil engineer with Intera. Please help me welcome Guillermo.
Can you hear me? Oh. Can you hear me now? Oh, yes. Thank you. Thank you for attending my presentation on enhancing groundwater modeling related to groundwater surface water interaction using remote sensing. I had it backwards. So this work is the result of a team effort, a research project developed for the Texas Water Development Board during the last couple of years. As part of this team, I would like to acknowledge several people involved with it. The team at Hassan and Sawyer, Peter, Mike, and Bernie were part of the report and leading the project. Chad and Jonathan in geosystem analysis. We did a lot of the remote sensing analysis and field work with drones. And Steve Young and Intera, who helped me doing the analysis related to groundwater modeling. I also would like to acknowledge the local agencies, Brazos Valley GCD, which provided access to the site, as well as the Post Oak Savannah, which is part of the jurisdiction in the area that we study in the Brazos River. Also important is to acknowledge the data providers, as they provide a great service to the state in terms of access to data that can be used by all. NASA and the French Spatial Agency provide the SWOT mission, which is the surface water ocean topography, from which we will be obtaining river stage. The USGS provided long-term stream records of USGS gauge data, Landsat images, and analysis of the surface of the river elevation. OpenET provided access to actual evapotranspiration that we use to develop seasonal factors of irrigation, and as well as other hydroclimatic data sets that we use to study research. Also, we'd like to acknowledge Darren Hardwick that provided a review of our report, which will be available soon. So in a few weeks, you should have access to this data set. We present our analysis in terms of use of satellite imagery and drones. I will focus on presenting some aspects related to groundwater modeling and the use of remote sensing. There was other efforts in terms of collecting data using thermal sensors, drone analysis, but I will focus on the results related to statewide coverage and access that is useful to augment or analysis of surface water interactions. So this is the outline. I will present you some ingredients for developing reliable surface groundwater interaction modeling. We will describe the area. Then we will go and briefly describe the remote sensing data products and the data portals that we can use to access to this data. We will continue with some examples on how we can derive seasonal factors and a brief sensitivity analysis if we have time. So this is kind of the description of what we call reliable, the recipe for this reliable groundwater surface interaction modeling. We need, the purpose of this is to provide defensible seasonal predictions on the interactions. The preparation time of this recipe takes several seasons. It's not easy to just go one side for one season and get an understanding of what is happening in the basin. And the hope is that we can provide some tools to guide decisions at the GCD and state level. So as you can see, there is a number of components that we need to have in mind. We need our equations that are summarized in our groundwater models. We won't go deep into that, but we will briefly describe the conceptual model or one of the approaches used. We will emphasize on the use of water budget analysis to focus our efforts and decide on what are the aspects that we need to analyze. Then another important part is to have measurements of the flows in between the aquifer at the rivers at the scale of our analysis. And that the scale of analysis is important to remember this should be guided by our decision of interest. The other component is to have an understanding of what are going to be the field methods to develop these properties that can help us to quantify the surface groundwater interaction and being able to measure those properties at those locations where we measure the flows. And here, what I will advocate is the use of or introducing factors of seasonality to improve our understanding of this phenomena. So, as you will know, the surface groundwater interactions are a complex phenomena that goes in hand with an understanding of the terrain. This publication, 1139 by the USGS, is an excellent document to provide or to summarize our understanding on them. We have gain and reaches where the groundwater level adjacent to the streams is higher than the water table of the river. We have losing streams where the groundwater table is below the top of the water and the water flows towards the aquifer. But there are other conditions, such as disconnected streams, where our river might be losing but not directly connected to the aquifer, or depending on the scale at where we're working, we might need to consider or not the effect of bank storage, depending on the speed on how the water levels in the river equalize with the surrounding aquifer. Briefly, what we are trying to say, we're attacking a difficult problem, a problem that goes into different scales. Groundwater is a phenomena that for the groundwater availability models, we generally work at an annual time step, whereas the dynamics of the surface of rivers works at a finer scales in terms of days or hours. So what we're doing with this analysis is just to notch down a little bit in terms of the spatial, the temporal discretization of the analysis by going into seasons. We don't have this data or refined seasonal data, so we are going to take advantage of the remote sensing to develop seasonal factors that allow us to get a better understanding. So I love to see the presentation of Rachel in terms of having a statewide access. So what I'm going to present here are data sets that are available for the entire state. For this particular application, we work with files from the central portion of the Carrizo-Wilkins aquifer, as you can see in the map, and we focus only in one reach, the Brazos, and the Brazos River in the particular location of the alluvial aquifer. And that's where we did all our analysis. There was some field work involved, and we analyzed or examined the benefit or value of different remote sensing data products. So this is a picture of the Brazos River, and in terms of our description of the phenomena, this is a sketch that describes how we represent surface groundwater interactions in this GAM. And the key component of this is we are looking at the difference. I'm hoping that I have the pointer on, and I don't. Yeah, I have it on here. We are looking at the difference between the head of the surrounded aquifer and the head of the river. And that difference we multiply by the terms called river conductance, and we obtain our flux. So that parameter is hard to obtain, it's hard to measure. And in this very basic representation of surface groundwater interactions, the modelers take upon defining this river head. And we are going to examine approaches to look into how we can represent that seasonally. This is a relatively simple representation of the groundwater surface interactions, but the complexity goes in terms of representing all the streams in an area. So this is a detailed plot of all the possible rivers and streams in the area. We also could use remote sensing to make an abstraction of how those streams will be represented in the model as they are here in the central, in this GAM, where we define the river cells, and where we define the flux in between the river and the aquifer. So for our study, we focus in this little ridge, or in this ridge, alluvial ridge of the Brazos, in between the jurisdictions of Brazos Valley and Post Oak, around 96,000 acres. And I'm going to present you a series of plots on how the riverhead and fluxes occur along this stream. But before we go into that, I would like to briefly discuss the role of water budgets in our analysis. Water budgets are a tool that allow us to understand the relative importance of different processes. This is a simplified sketch of a cross-section of a river where we are represented by arrows the flux of water in between different units. So we have our recharge, the groundwater surface interaction between streams and the surrounding alluvium, and the flux and the possible flux that we can have between the alluvium and the underlying aquifer. So what we do with water budgets is to have a temporal representation of these fluxes over time. And what we're trying to understand is how these fluxes change over time as a result of natural drivers such as recharge or anthropogenic effects such as pumping. So this is a condition of a gaining stream where at this time or this moment in season there is no pumping or groundwater levels maintain above the stream, but as we eventually in one part of the year we can have pumping and have our groundwater table change and our fluxes do accordingly. So what we do with the water budgets is to define an area of interest where we calculate the flux, the net flux in between these units to understand what is important and to understand what part of the analysis we need to refine. So we did this analysis for different areas of interest along this area, and we produce this type of plots where we draw, where we represent how these fluxes change over time. And as you can see, pumping in the later part of this GAM increases in the alluvium. The exchange of the river is large and decreases over time, and we have recharge also being an important aspect here. So these are the three main components which we will be examining closely with the use of the seasonal factors. But before of that, I would like to present you a couple of plots that inform in terms of how we visualize the interactions. As you remember, as you recall in the previous slides, the key is the difference between the head of the aquifer and the river, and these heads are represented by this thin blue line here, and the stage of the river is this orange line. So in this condition in the 50s, groundwater levels were above the stream, and as you can see in the plot adjacent to it, this is sorting the cells along the river. You can see again in the stream, all blue. Later on in the simulation in 2010, there is a lot more pumping as represented with these green cells. And as you can see here, you can see how the groundwater head changes with respect to the river. So why I'm emphasizing so much in this plot is because I will present you later a tool that will allow us to explore the seasonality of the river table for locations for large rivers in Texas. So with that, I will now go a little into discuss in more detail the products available at the state level. So the first one is SWOT. As I mentioned, is surface water and ocean topography. There is a portal by the USGS that allows you to access this data. And right now, these are the main streams, it's the major rivers. Probably will be for a while because it's only been in operation for a year. But another important thing is they also provide lake elevations, which might be of interest when trying to understand particular site conditions. The other product is actual evapotranspiration. This comes from Landsat, a satellite operated by the USGS. And we take advantage of the processing of done by OpenET to have a estimate of how much water evaporates at any particular location in the state of Texas. So this is a map. This information is publicly available. So going in a little more detail on this, you can see the interface of the size of the USGS. Right now, you just go there and you can query for any river, seasonal estimates every 10 days of the river elevation. And for some locations, you can compare with the available estimates from the USGS in terms of flow. And you also can query lakes and get an understanding of the seasonal variability of these bodies over time. And then for me, this is the coolest plot of the presentation. Sorry, I'm too passionate about it, but this is the information of the GAM without us doing anything. It's just the reference elevations that we have representing the groundwater-surface water interaction with the elevations from this satellite. And what we are showing here is different levels of flow measured during 2024. So what we can obtain from this satellite are spatial estimates of our riverhead. And we can use this information to augment our understanding of the seasonal variability of the river stage. And as I mentioned before, it's a key aspect to have a better understanding of our water budget in this particular location. So this is the data that we use to develop these seasonal estimates. And just to reiterate, the blue indicate low flow levels, the red indicate high flow levels, and we had this, we can use these to compare to the reference elevation that we use in our model. So we did a statistical analysis to understand the seasonal variability of flow and river stage at every quarter in the entire record of available for this particular gauge in the Brazos River. We tried at first for this screening analysis just to come up with a seasonal factor, average seasonal factor that we could introduce in our GAM that runs in the past, runs from the 40s to 2010. But we use it as a proof of concept. So based on understanding or seeing that there is a pattern in the seasonality of river stage and flows, we compare that with the long-term annual flow in the basin, which is represented by this dotted line. And we have estimates of flow for each quarter. So on average, you can see that the flow during the first quarter of the year between January and March is very close to the long-term annual flow. Then our river stage on average increase during the second quarter of the year, then goes down during the summer, and then increase a little bit in Q4. We can know this just from the river gauges. But the value that we can get from SWOT is that we can develop functions to interpolate between the flow values that we want to examine and the average difference in terms of river elevation. So that's what we did here. Yes, this plot has only a few data points because it's only for 2024. We're just learning how to use this data, but shows the potential of how we could use this information available for the entire state to have a better understanding of seasonal variations on water, of surface water, and how potentially in the future we can develop much more refined models that take advantage of all these availability of data. So this is the development of these seasonal factors that are represented here in this column. And we use it as multipliers, as we use an approach using PES to understand what is the effect of these variations, seasonal variations on our simulation. The other product that I want to mention here is the use of OpenET, where we can access estimates of evapotranspiration for any location in Texas and understand what is the water that is being evaporated. And then from there, we develop a basic estimate of irrigation where we subtract some effective precipitation from the evapotranspiration that we had from the satellite data, and we obtain this rough estimate of irrigation. This estimate can be refined with models that take into account soil moisture, but for this screening analysis, we just did it this way. And the advantage of this is we can, for certain areas when we want to understand or have a better handle of the spatial variability of irrigation, we can develop these estimates as shown here. So those are the 3 factors that I mentioned earlier. And from there, we develop as well these seasonal factors for irrigation. So based on the remote sensing data, and considering that at this location in Texas, most of the pumping is used for agricultural use, only a small fraction will happen during the first quarter of the year, 30% during the second quarter, and close to 60% during the third quarter. So we have this seasonal variability that now we can integrate into our more detailed seasonal analysis of the groundwater interactions. So that's what we did at the end of, or what we present in the end of this report, where we incorporate or combine the pumping factors obtained from OpenET, recharge factors developed from hydroclimatic data sets, and river stage factors developed from SWOT. We also look into the importance or the relevance of conductance, something that for which we don't have very little data. It's very difficult to have field estimates of conductance along these streams. So what I'm going to show you next is a couple of examples of how we use these seasonal factors in a simulation using the gamma, the central Carrizo GAM. So this black line for a particular cell along the Brazos River shows you the groundwater head. And then gradually what we do is incorporating the impact of seasonality due to pumping. So at the end here, this is the full seasonal factor that we have. And then we can see now how our groundwater table adjacent to the river is capturing that seasonal dynamics. So this is one example of that. Our hope was to be able to compare what we obtained in the field to this. We had challenges doing that, but we developed the framework to prepare future analysis. So this is one example in terms of groundwater head. This is similar in terms of the flux at a particular location, in case we are able to measure or have a proxy for what is the flow in between the stream and the aquifer. And what is interesting of this plot, it looks a little heavy, but if you bear with me, the black line will represent a GAM or will represent an aquifer where we don't take into account this seasonal variation, whereas the purple line here represents that seasonal factor. And as I mentioned before, there will be gaining and losing stream. So if we look into the seasonal variation, we can see now how at the end of the simulation, we start to see that particular location of our stream will be a losing stream. Whereas if we don't consider the seasonal factor, it will be always gaining. We can aggregate this into what is the total contribution of the flows and compare in terms of what will be the most relevant or important aspect where we need to put our energy. And finally, this is what I feel is going into the value of how we can augment our parameters this is a simple sensitivity analysis without including seasonal factors where we get estimates at a particular location of the groundwater head and the flow. And this is one where we incorporate the seasonal factors. What we can see here is there is a clear pattern that we can then examine or compare. If we apply, we then are able to see which pattern of flow will be more consistent with the observation. I think this is the value. We have, by introducing the seasonality, we have now additional pieces of information to inquire in terms of how reasonable the estimates from our models. So as a summary, I briefly presented these ingredients for reliable groundwater surface granule interactions. We present you some tools readily available for you to explore in terms of understanding spatial variations of surface water and irrigation. And with the example presented here, we hope to infuse the idea of having these methods for quantifying seasonality in order to have a better understanding of the interaction between rivers and aquifers. And with that, I'm happy to answer questions. Thank you.
Okay, any questions for Guillermo?
Hi, very interesting presentation, so thank you. And forgive my ignorance, because I am not a modeler myself. A lot of the information that you showed seemed like it would be involved in like a model calibration using like historical data sets. Do you foresee this modeling going into like predictive, so looking at future scenarios where you can add in wells and see if they are pumping this much, what impact that could have on the river system?
Yeah. The original intent of this project was to provide additional tools to improve our calibration or an understanding of the surface groundwater interactions. And yes, we had the hope that introducing this type of data and rigor in terms of represented seasonality will help us to have better predictions and understand the impact of, let's say, changing pumping or shifting the season, etc. Thank you. Thank you.